like images, like text, which are very popular. Okay, uh, images and text are and sound. They are uh, three very important types of data: images, text, and sound. These are three types of data that are very important, and many of the applications that we have and the software that have been produced in artificial intelligence, they are working on these types of data. For example, if we have a video and we want to do a analysis on this video, okay? For example, we have a video of a event, okay? And we want to do an analysis on this video. This could be done by deep learning, okay? Processing videos and images are a very important subject that we have, and this could be done using deep learning. So deep learning is a field in data mining, and as I said, there are some advanced neural network architectures. They are very deep session. I said that we want to talk about a special type of deep learning, which is convolutional neural networks. Okay, this is a special type of architecture in deep learning, and it is very popular, and it is mostly used for images and videos, but it is being used for text and other data too. But in the images and videos, it has very good results, and it has been used very much. I said that this CNN, it was inspired from uh, the nature. I talked about this in the previous session. Okay, uh, in the previous session, we were talking about this slide. I said that we have a database of images, and the name of this data set is CIFAR 10. CIFAR 10 is a image dataset. In this dataset, uh, 10 we have 10 different classes. Okay, airplane, automobile, bird, cat, door, dog, frog, horse, sheep, truck. Okay, these are the different classes of images we have in this dataset, and you see some of these images in this slide. Okay, of for example, the birds, the airplanes. Okay, uh, okay. So this is this is an important data set. Okay. Uh, okay. One of you have a question about the assignment. About the assignment. Okay. You said, Mrs. Resha. You said I have changed the assignment. Uh, w- when did I change it? Because in the course, okay, in the course I said that uh, I talked about first. I talked about the assignment in one of the online sessions. Yes, in that session, I said that uh, the assignment is naive Bayes classifier. Okay, but I didn't I, I I didn't teach about the naive Bayes classifier. Okay, so uh, I I put the file on the site, the exercise in the site. It was the neural network. Okay, is that okay, Mrs. Rasha? Because I only teach you about neural networks. Okay, and the assignment is about neural networks. Okay, what did I change? Yes, in the lesson. What, Mrs. Rasha, what assignment did you solve? Could you tell me what was the assignment that you solved? Do you have my voice, Mrs. Rasha? What was the assignment that you solved? Okay, I think Mrs. Rasha is not a problem in the internet. Okay. Okay, what? Uh, mm, okay, Mrs. Rasha, what was the assignment that you solved? Could you tell me, please? Okay, okay, no problem. No, um, and no problem. Okay, the first assignment was about neural networks, and you have time. If you could send the uh, uh, your solution uh, with more time. You have two days, 2 more days to send your solution. Okay, no problem. You can send your solutions after 2 days. Okay. Okay. I was talking about CNN, and CNN is advanced neural network structure. Okay. CNN is an advanced neural network structure. And I said that we have a data set, CFAR10. CFAR10 is a data set of images, And in this data set, we have 10 class of images. Okay, we talked about the different classes of data. We said that in classification, we have some a limited number of classes. For example, where we talked about the example about fruits, we had two classes, apple and pear. Here in this data set about images CFAR 10, we have 10 classes, 10 class of images. And what do we want to do? We want to classify these images. Okay, so we want to do, we want to design a classifier for classifying these images. Okay, so uh, this data is image data. Okay, the data, the type of data we are talking about in this example is images. Okay, and uh, how could we represent the images? Okay, okay, I talked about this a little, but I will talk about it more in this session. Uh, okay, assume that this is an image. Okay, assume that this is a image, and this image, this image, it is composed of some pixels. Okay, these every uh, every little part of the image is a pixel. In your mobile camera, it has a resolution, for example, 10 megapixel. It is the resolution of the images that you have in your camera. It means that the images have this number of pixels, 10 megapixel. 10 megapixels means about 10 million pixels in each image. Okay, so the images that are 10 megapixel, they will be very good images. Okay, with high resolution. So pixel is uh, uh, the smallest part of an image. Pixel. Okay, each pixel each pixel is a number. Each pixel is a number. Each pixel is a number between 0 and 255. Okay? Each pixel is a number between 0 and 255. It is a whole number. It's not a float number. Okay? It means that the values are 0, 1, 2, 3, 2, 255. Okay, and this value is the uh, intensity of each pixel. Okay, if we have a black and white image, if we have a black and white image, okay, in the black and white images, the value of this value of the pixel, uh, okay, 0 means black in the black and white image. Okay, 0 means black, and 255 means white. Okay, so in the black and white image, 0 means black and 255 means white. Okay, so the lowest pixel value, it is representing the black pixels. If you have some black pixels in your image, in your black and white image, they will be, the value of those pixels would be 0. And if you have some white pixels, they would be 255. Between these two values, 1, 2, 3 to 254, they are called, they are gray uh, values. Okay, let me show you and something that you could better understand this. Okay, do you see this image? Do you see this image here? I have uploaded for you. Can you see it? Do you see this image here? Okay, you see this. This is white. Okay, this is white and this is black. This is white. This is black. This is the pixel value 255 white. Okay, and the black is the pixel value 0. And here you see we have some gray. These are the values between 0 and 255. For example, the value 100 or the value 50. So in the black and white image, we have these colors. Okay, we only have colors that are between black and white. Okay, do you understand this? This is what we have in the black and white image. Okay, it is called it is called the gray scale. Okay, they call it gray scale. Let me write it here. Okay, gray scale image. Okay, they call it gray scale image. Gray scale image is it is a black and white image that the colors are only gray. The colors are only gray. They start from black. Black is the 0, and they come until they reach white. White is the highest value in the black and white image. Okay, so this is the pixel values. This is the pixel values that we have in a black and white image. Okay, it's something like this. Let me write it for you. Okay, do you see these numbers I have written here? Do you see these numbers? Do you see these numbers here? Okay, these are some, for example, these are some pixel values. Okay, for example, we have an image. We have an image that has that the resolution of this image is this. The resolution is 2 multiplied by 4. Okay, 2 multiplied by 4. Okay, we have 2 rows and 4 columns. So the resolution is 8 pixels. Here we only have 8 pixels. Okay, do you understand this? So this is the resolution of the image, the number of pixels that we have in the image. Okay, do you understand this? No problem. Okay, so this is the images. This is black and white image. Okay, this is black and white. Okay, let me show you let me show you example of color. Okay, okay, here I said that here we have a matrix. Okay, we have a matrix here. We have a matrix here. Okay, this matrix is an image. Okay, I said that the image, it has some pixels. Okay, the image has some pixels. In this example here, as you can see it, we have 8 pixels. Okay, 1, 2, 3, 4, 8 pixels. Okay, so we have 8 pixels, and these are, for example, the values 0, 30, 34. Okay, this 0 is black, this 255 is white, and this is 100. These are gray values. Okay, you understand? Yes, the image. Yes, the image has many more pixels. Okay, 1,000 is very little. Okay, as I said, if you in your camera, in the mobile camera, the resolution is, for example, 10 megapixel. 10 megapixel means 10 million pixel. Okay, so you have a very good uh, image. You have a very good image. 10 megapixel. Okay, so 10 megapixel means we have 10 million pixels in the image. Here is a very simple example, 8 pixel. 8 pixel. Okay, but in the real images, the resolution is very high. Okay, uh, so this is the black and white image. Okay, but most of our images are not black and white, and they are color images. Okay, they are color images. In the color images, what happens? I said now that in the black and white image, we have the colors. The colors that we have are white, black, and gray. But in the color images, okay, we have many different colors. But these colors are built based on some color modes. Okay, for example, one of the color mode or color models that we have is RGB. Okay, RGB. RGB stands for red, green, blue. RGB. RGB, it means red, green, blue. Okay, red, green, blue. As you see here, we have these three colors, and all of our colors are built using these three colors, RGB. Okay, all of our colors are built using these RGBs. Okay, now each of these, okay, R is red, G is green, and B is blue. Each of these three colors, they have, as I said, in the black and white image, we have one only, uh, we have only one matrix, and the values are between 0 and 255. But in the RGB, we have three matrices. In the RGB, we have three matrices: one for red, one for green, one for blue. Red, green, blue. Okay? Okay, we have three matrices. Okay, one for red, one for green, one for blue. Okay, let me write it here for you. For example, uh, R G B. Okay, can you see this here? RGB. You see it? We have these RGB. Each of them are a matrix. RGB. Each of them have some pixels. Okay, very similar to the black and white image. We have in the black and white image we only have one matrix, and the colors are between white and black. But in the RGB we have three matrices, one for the red, one for green, one for blue. And the values that are inside these matrices, it defines the intensity of the red, green, and blue. Okay, for example, okay, here in the first pixel, okay, this is an image with 3 pixels. This is this example here that I have written, RGB. You see it has 3 pixels. Do you understand? 3 pixel, only 3 pixel. In the first pixel, the R value is 0. It means we don't have red. Okay, when R is 0, it means that in this color we don't have red. And the green is 50, so we have more green, and the blue is 30. Okay, and here in the second pixel, okay, the the red is 10. Okay, we have some red, and we don't have green in the second pixel, and we have some blue. And in the third pixel, we have the same number of value for R, G, and B. Okay, when we have the same number of values for this makes a specific color for us. Okay, let me give you an example of this. Okay, look at this example here in my screen. Can you see this? Can you see this? Can you see my page? Okay, you see here we have RGB. We have RGB. Okay, I will put the value R 100, G 100, and B 100. Okay, this is the color. This is the color. Okay, it's a gray color. If we have R 100, G 100, and B 100. Okay, if for example I put R 0 and G 50 and B 30. Okay, this is the color. This is the color you see. Okay, so using these three values we could build some colors. Each of them is a pixel. Each of these are pixels. Okay, do you understand this? So in the color image, it has different color modes. It has different color modes. This is RGB. RGB. In RGB, we have these three colors RGB, and using these colors, we build our color image. Okay. For example, if we put R is 255, okay, you see it's red, and G is 0, and B is 0. Okay, this is a red color. R is 255. Okay, so this is the RGB. Okay, now I was talking about this example. Okay, in this data set C410 we have color images. Okay, we have color images, and the image size that we have in this C410, it is 32 multiplied by 32 multiplied by 3. Okay, 32, 3. This 3 is the RGB. RGB, they are free. Okay, 32 by 32, it means each of the images that we have here, okay, the images, the size of the images are 32 pixels by 32 pixels. Okay, do you understand that? Each of the images, their size is 32 multiplied by 32. So each image, it has about each of these color images that we have here, each of the color images, they have 3072 pixels. Okay, 32 multiplied by 32, it is 124. Multiply and 124, sorry, 32 multiplied by 32 is 124. I'm sorry. Okay, this is the number. What's the problem here? Okay, so the number of pixels that we have in each image is 372. Okay, so this is the resolution of the images that we have. Now, if we want to use a neural network, okay, we talked about this. And now you know what is an image. Okay, you know what is the image data. If you want to talk about the image data, you see that each image, it has many pixels. Okay, each of the images has many pixels, and those pixels are the inputs of the image. Do you remember we talked about the fruit example? In the fruit example, we said that each fruit has two inputs, color and height. So each fruit has only two inputs. But the image here, the color image here, each of the images, they have 3072 inputs. Okay? Do you understand this? Each of the images have 3072 inputs. Each of the pixels is an input in our data. So if we want to have a neural network, if we want to have a neural, yes, each of the images in this example, okay, each of the images have 3072 pixels. Each of the images have 3072 pixels. Okay, these pixels, they are the inputs of our data. For example, if we want to uh, in this in this data set CFAR 10, what do we want to do? We want to classify the images. We have 10 classes. Airplane, okay, do you understand this? We have 10 classes. The classes, the outputs of our data, they are 10 outputs. Airplane, automobile, bird, okay, these are the outputs. But the inputs are the pixels. The inputs are the pixels. Okay, so each image has many inputs. If we want to enter an image into the neural network, the neural network should have 3072 inputs. Okay, say 3072 inputs, and these will enter. So we would have a big neural network. You remember we said that the neural network is fully connected. Fully connected means that all of the uh, outputs of each layer are connected to all of the inputs of the next layer. Okay, do you remember the neural network had two layers, hidden layer and the output layer? Yes. So that when if we want to enter an image into the neural network, it will have a very big neural network with many parameters, with many parameters, and this is not efficient. This is not efficient. Okay, so so usually we don't enter an image into the neural network. Okay, this is not good. Okay, because the number of inputs are very high. Okay, in the CNN, I said it is an advanced neural network. It is an advanced neural network, CNN. Okay, we could, in the inputs, we could have some neurons that are three-dimensional. Okay, so we could enter the data better into this CNN. Okay, so in CNN we have three-dimensional neurons. As I said, we have RGB, three dimensions, RGB. In the CNN, we have three-dimensional neurons, and so this data could be entered better. So here in the CNN, we will have 1024 neurons. Okay, in the CNN, we will have 1024 neurons that the image would enter the CNN. So because we have three-dimensional neurons, the number of inputs in CNN is less than the number of inputs in a normal neural network. Two, what do you mean 2 to power 10? Okay, so CNN, it has less inputs than the normal neural network because they have three-dimensional neurons. So the number of inputs in CNN is less than a normal neural network. Okay, that's what we are saying in this slide. That's what we're saying in this slide. Okay, you understand? The number of inputs in CNN are less than the number of inputs in normal neural network because here we have three-dimensional neurons. Okay, so in the CNN, This is the general architecture of CNN. I'm sorry. Okay. Uh, the CNN architecture is like this. Okay. About the assignment. Okay. I said that you have more time. You can send it. No problem. Okay. You have more time and you can send it. No problem. Okay. The CNN. The CNN architecture is like this. This is the general architecture of the CNN. Okay, it's like this. Here is the input layer. Here is here we have sorry, here we have the feature extraction layers, and then we have the classification layers. Okay, so the in the CNN architecture we have two main parts: the feature extraction layers and the classification layers. Okay, in the CNN we have two main parts: the feature extraction layer and the classification layers. Okay, now what do we mean by feature extraction? What do we mean by feature extraction? Feature extraction layer, and what do we mean by classification layer? Okay, we will talk about this in the next slides. And the input layer is for inputting data into the neural network. Okay, the input layer is for inputting data into the neural network. The input layer, okay, is for inputting data into the neural network. And so this is the input layer. No problem about the input layer. Okay, do you understand? Okay, so this is the input layer. The input layer, it gets our input. If our input is a color image, okay, usually if if our data are images, okay, usually the input is color images. Most of our images are color images. Okay, most of our images, they are color images. So okay, this is the input layer. So the input layer gets the three-dimensional input, and that's what it does. Okay, it's getting the three-dimensional inputs. The next layer, that is the most important layer in the CNN, it is the feature extraction layer. Okay, the feature extraction layer is the most important layer that we have in CNN. Okay, and this layer, what is it doing? What does feature extraction mean? Okay, it's very important. Feature extraction is a very important task in data mining. Okay, as I talked, as we talked in the previous slide, in the image we have many pixels. For example, if the image resolution, if the image resolution is, for example, 800 multiplied by 600, okay, 800 800 multiplied by 600 is 40 400 and 480,000 pixels. If the image resolution is 800 multiplied by 600, okay, this, if this is the image resolution, we have 480,000 pixels. Okay, we have 480,000 pixels. Okay, do you understand this? When the image resolution is 800 by 600, it means we have 480,000 pixels. So it is very much pixels, and uh, and many of these pixels are not good. We don't need them. Okay, many of the pixels, we don't need them. Many of the pixels, we don't need them. What is feature extraction? Feature extraction means that we are extracting some information from these many pixels. Each image, if the resolution is, for example, if the resolution is 800 multiplied by 600, it would be 480,000 pixels. Or if the resolution is 32 multiplied by 32, like in the CFAR dataset. Okay, in the CFAR dataset, we said that the uh, the the resolution of the image is 32 multiplied by 32. So and then multiplied by 3. Okay, so the resolution of the image is was 3072 pixels. Okay, now what does feature extraction do? Feature extraction, it wants to extract some information from these pixels. Instead of entering, instead of entering all of the pixels into the neural network, we will extract some a smaller number of data from the pixels. Okay? Instead of entering 3,000 data or inputs into our neural network, we will enter much less data. And this is called feature extraction. Feature means the inputs. Okay? Do you remember I said that in the data that we have in data mining, we have some inputs and outputs. The inputs are the features. Feature extraction means that we want to set up the inputs. We want to build the inputs. Okay? We want to build the inputs. Okay? We want to create the inputs. If we give the whole image to the neural network, that's not efficient. That's not efficient if we give the whole image into the neural network. But if we build it, if we select some data from this image, okay, not select, we want to build some data, build some inputs from this big from this high amount of pixels. This is called feature extraction. Feature extraction is building some features from for example, an image. An image has many pixels they are not efficient to give all of them to the neural network. We want to build some less number of features and give the features to the neural network. Okay, you understand what does feature extraction means? Okay, let me show you this image again. Let me show you this image. Okay, you look at this image. This image is tells what we are doing. Okay, look at this image. Okay, you see it. It says that this image, it is being converted to this, and then to this, and then to this. Okay, this is feature extraction. This is feature extraction. This image, okay, this is an image with many pixels, and then we have converted it to this. This is feature extraction. Okay, we have extract. How do we do it? Okay, how do we extract this data? I will talk about it in the next slides. I will talk about how do we extract some features from the image. Okay, so feature extraction means that I have this image with many pixels, and then I convert it to this with much less. Okay, you see that here, for example, it has 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 5. Okay, this matrix, it has 56 numbers. Okay, compare 56 with 1,000 or 3,000 is much less. Okay, so this is feature extraction. We are extracting some data. We are building some inputs from our initial data. This is called feature extraction. It's very, very important in data mining. In some data like images, we have to do it because we don't give all of the pixels into the learning model. Okay, we have to do feature extraction. But in some examples, we don't do it. For example, in the example that we had about fruits, in the fruit example, okay? Do you remember? Each of the fruit, they had two inputs, color, height. In this example, we don't have feature extraction because we only have two features. But in the image data, in the text data, in the sound data, okay, in all of these complicated data, we have to do feature extraction. We have to build some features from the original data. That's called feature extraction. Okay, that's what we are doing in CNN. The most important part, the most important part of CNN is feature extraction. Okay, that's the different. Uh, uh, we didn't have this part in the normal neural network that we talked in the previous slides. Okay, the normal neural network, it only had hidden layer and output layer. It was only for learning. The okay, the normal neural network, it was only doing learning. But here in the CNN, we are doing something else. Except of learning, we are doing learning too, okay? But we are doing something else too, which is named feature extraction. That's the most important part of CNN, and that's the main difference of CNN with the normal neural network. Okay, do you understand? No problem? Okay. In the feature extraction layer, we have two layers. Okay, we have two main layers. In the feature extraction layer, we have two main layers. It is the convolution layer and it is the pooling layer. These are the two main layers that we have in the feature extraction layer. Okay, so in the feature extraction layer, we have two main layers, convolution layer and pooling layer. These are the two main layers that we have in the feature extraction layers. Okay, now what happens in the convolution layer? This is the most important layer in CNN. In CNN, the most important layer that we have is it's called the convolution layer. Convolution layer. That's the most important layer that we have. And what does convolution mean? Convolution is a very important task that we have, and this is the definition of convolution. Okay, this is in this figure you see what is convolution doing. Okay, that's what happening in the convolution layer. Okay, for example, assume that this is our data. Okay, I told you that this is the input data. Okay, I told you that the image is like a matrix. Okay, I said that the image is like a matrix. Okay, this is the image. This is the input image that we have here. Okay, okay, and you see that the pixel values are only 0 and 1. This is a very simple example. Okay, okay, and then we have something else called the kernel or the filter. Kernel or filter. So we have the input image and we have a kernel. And what is happening in convolution? What is convolution? In convolution, this kernel, which is a matrix, this kernel is moving on the input image. The center of this kernel. The center of this kernel is here, okay? This is the center of the kernel. This center, it is moving into this matrix here. Okay, for example, this kernel matrix, it could be here, the, the center. It could be here, it could be here. In this example that you see here, the kernel matrix center is here. Okay, and then what happens? The numbers that are inside this kernel, they are multiplied by the numbers that are in the image. Okay, you see it here. Okay, let me zoom it that you can see it here. Okay, you see 1 multiplied by 1, 0 multiplied by 0. Okay, this is 1 multiplied by 1, 0 multiplied by 0, 1 multiplied by 0. Okay, all of the pixel, all of the values, they are multiplied to each other, and then they are summed up, added to each other, and the result is 4. So when this kernel is put into this place, and each of the values are being multiplied and then they are added to each other, the result would be 4. This is the result. Understand this? What does convolution mean? This put image, and in each place that it's moving, all of the numbers are being multiplied and added to each other, and the result is put here. Okay, that is convolution. That's convolution. Okay, so as I said, the center of this kernel, it is put, and it is moving on the input image. Okay, the for example, when the center is put here, okay, the result is 4. When it is put here, the result is 3, and when it is put here, the result is 4 again. So this is convolution. In convolution, we have a kernel. It's moving on the data, and in every place, it is uh, it is creating a result, which is from the multiplication and the addition of data. That's what's happening in convolution. Okay, you have a question. You say that kernel is fixed to this value. No, no. Okay, no. The values that are in the kernel, they are not fixed. They are not fixed. Okay. I will talk about this. Is very important. This is a very important point about the convolution. The values in the kernel. They are. This is very important. Yes, yes. The data is being reduced. Okay, the data is being reduced. Yes. Okay. Why does this happen? Why does the data reduce? Because, okay, because this kernel, it can't move on these places. If we put the center of the kernel here in this place, okay, okay, it can't do anything because uh, we don't have data here, okay, in because the first the the reason for the data reduction is that the kernel could only move here 1 2 3 4 5 6 7 8 9. It could only move in these boxes. So we have uh, 9 results only. Okay, so this is convolution. Convolution is the movement of a kernel on input image, and it is creating some data for us. Okay, uh, I'm sorry. I will be back in 5 minutes. Okay, I will be back in 5 minutes. Have a 5 minute break. Thanks. Okay, I'm sorry. Do you have my voice? I talked about convolution. Convolution is the main operation that we have in the convolution neural network or CNN. Convolution is the main operation. The convolution is the main layer that we have. Okay, we talked about convolution, and uh, in the convolution layer, we have some important concepts. Okay, one of them is filter. Filter is the kernel. Okay, this is the filter kernel. Kernel is the matrix which is moving on the image and is doing some operation which is a multiplication and an addition. Okay, uh, okay. The filters. Fil- uh, this is the filter. Okay, this is the kernel, the matrix that is moving on the data. It's called the filter or the kernel. Okay, okay. Each neuron, each neuron in the convolution layer is a filter. Each neuron in the convolution layer is a filter. This is very important. Okay. In the convolution layer, we have some neurons. Do you remember that we talked about the perceptron and the multi-layer perceptron? Okay. The neuron in the perceptron, it had some inputs, and then it was adding up the inputs and get output. Okay. In the convolution layer, in the CNN, the convolution layer, each of the neurons are a filter. Each of the neurons are a filter. Okay, for example, here I have a filter with the size 3 multiplied by 3, 3 by 3. Okay, it has 9 values inside it. So this is very important. The number of neurons. Each neuron in the convolution layer is a filter or a kernel. Okay, do you understand? No problem. This is very important. Okay, we will come back to this again. The second the second concept about the convolution layer is the activation map. Activation map. What does activation map mean? Activation map is the result of the convolution. Activation map is the result of the convolution. Okay, here in this example of convolution, I said that this is the input, this is the kernel, and this is the result. This result is called the activation map. Activation map is the result of the convolution. Okay? So, activation map is the result of the convolution. Activation map is the result of the convolution. For example, if I have if I have 5 neurons in the convolution layer. Okay, so in the convolution layer, I have 5 neurons. Each of the neurons is a filter or a kernel. And when it is moving on the image, it will create an activation map. So in this example, we will have 5 activation maps. 1, 2, 3, 4, 5. 5 outputs in this layer. For each of the filters, we will have an activation map. So I have 5 neurons in the convolution layer, and each of these neurons is a filter, and okay, each of them is creating an activation map. Okay, you understand this? No problem. Okay, before I continue my subject, I should say one important note about this CNN. Okay, as you remember, we said that in the neural network, the parameters were the weights. Do you remember? We said that the parameters and the unknown values of the models are the weights. Okay? Do you remember that? In the neural network, learning was setting the weights of the neural network. Okay? Learning was setting the weights. Now, in this neural network, the CNN, in the convolution layer, what are the weights? What do we learn in the convolution layer? This is a very important question. What do we learn in the convolution layer? What is the learning for the convolution layer? Okay, the answer is that the learning of the convolution layer and the weights that are being set in the convolution layer are the values inside this kernel. So, one of you asked, is the values inside the kernel fixed? No, they are set in the learning process of the convolution layer. Okay? So, the parameters which are set in the learning of the convolution layer are the values inside the kernel or filter. Did you understand this? So the values inside the kernel, they are set in the learning of the convolution layer. This is a very important point about the convolution layer. Okay, the parameters that are being learned in the convolution layer is the values inside the kernel. Yes, the values inside the kernel are the weights, the values, the numbers. The numbers inside the kernel are the weights. Okay, thanks. Thank you very much. If you have any question, please ask. About the assignment, you have uh, um, 2 more days time. Uh, you know the okay. Don't worry about the assignment. You have two more days to send it. Okay, no problem. Okay, thanks. I hope you have a good time and you are healthy.